Today I'm going to show you how to use the Proto-Ject line of machines. We're going to set it up, be it a 300 or a 150. We're going to set it up to shoot a mold and show you some of the controls and talk about some safety aspects and that type of thing. So let's get started. The machine has a clamp. This clamp holds the mold in place, and you can use different size molds. We're going to set up this little guy here today, and he'll go right in here. But as you can see, the clamp moves in and out because sometimes you got a big guy like this right here that you need to put in there. So in that case, you'd open up the clamp nice and wide, you pull it out, and because it won't go between the stanchion rods, now you can insert it out here, put it in, clamp it in place. So that's a video for another time. But today we're going to concentrate on getting the machine set up for this mold right here. This mold makes a little, like a little key tag or something. It's just sort of a novelty mold. It's a good practice type mold. So first thing we want to do is we need to get the mold up level to this notch in the back platen. It doesn't have to be level with it, but I mean, for example, you could do this. If you have a nice thick back, it's not a problem. But if your back is thin, this one's pretty thin, you need to get the mold up pretty close to this notch. So we do that with a spacer. Now we sell a mold kit, a shim kit that you can use to shim the mold up in 1/8 inch increments. And that is something that's available. You just have to contact us for that type thing. But so today, because we're using such a thin, small mold, we can push the machine back, get it centered under the nozzle, and actually lock these screws down. So let's do that. First thing we'll do is we'll center it front to back. So if we can just look right over here, and we can see that the sprue opening and the parting line of the mold needs to be centered right under the nozzle. And we can retouch on this if we need to. And so that looks pretty good. Now we have some work to do this way, but we've got it back and forth. So now if we look here at the back, we're going to adjust this clamp, this mold stop. I'll get right in a minute. The mold clamp stop. We're going to adjust that. So now, if we did want to move it in and out, it stops and registers at a specific spot every time. So if we like that, we can go ahead and we can lock these down. You can lock them down finger tight. If you want, you can use a wrench to even snug them down more. So you'll probably find that that's probably good enough, and it won't go anywhere on you. So, okay, so we've kind of got front to back adjusted. You can screw in a little closer. But as we can see right here, left to right, we're way out of alignment. So the next thing we need to do is adjust this right mold stop. And so we'll reach around here, and I'll keep sliding this left. And if we'll look right here at the very front, we'll see when we have it pretty much centered under the nozzle. And let's say that's good for now. Okay. So now we can go ahead and we can just crank this down. There we go. So that's good as far as front and back and left and right. The other thing though that we have to concern ourselves with is the nozzle can't be too far from the mold. There's a couple reasons for this. First off, it's just safety. We want it pretty close so that accidentally we don't get a finger or something under there. And although it's a hot nozzle with a hot tip, so you don't want to be touching it anyway. But that's part of the reason. The second reason is because if a lot of your motion of the plunger is used to just simply lower the nozzle to make contact with the mold, then that is less of the plunger that can be used to actually inject material. So you'll be able to inject less material for like larger molds. So if you've got a large mold that's got a big cavity, you want to get this down here as close as possible. Now you want it to be close enough that, or far enough away rather, that you can reach in here with some type of tool. It can be something like these large hemostats or some needle nose pliers, something like that. But that's really about all the gap you need. So the next thing we're going to do is we're going to lower the machine. Now this machine can accept all kinds of clamps. There's the base machine can come with basically a heavy duty vise. This is the Manning Innovations manual clamp. We have hydraulic clamps. There are clamps where the platens go this way and clamp vertically. So you can put more traditional type molds where you inject through the side of the of the mold rather. This is what we call parting line injection because it injects at the parting line. We like that because it saves a lot of real estate on the mold. And when you have molds this size, real estate is kind of at a premium, so it allows you to get by with a smaller mold in order to make an item. Also, it takes less plastic because you don't waste a lot of plastic injecting into a sprue that then goes into runners and then into a cavity and so forth. So we kind of like the parting line injection. So, all right, so let's see. So we need to adjust the height of the machine, and that's what these do. These accommodate whatever type of clamp that you have. You can use one type of clamp at one time, and let's say you need a 15-ton or a 25-ton hydraulic. You can take this out and put a larger clamp in there and accommodate much larger molds. Maybe over time you can grow or what have you if you need to have more clamping forces. So first thing we're going to do is we're going to loosen these. I've already loosened some of these here because I knew we was going to need to let it down. So for expediency, you can loosen these, and they can use a wrench then to kind of lower the elevation. You can see as we're coming down, we're also seeing that we might have to readjust the left to right a bit. Now that's a pretty good distance. You can still get under there and pinch off any plastic that might need to be, but it would be harder to accidentally get your finger pinched or something in there if that were to be an issue. So we're going to loosen this a little bit, and we're going to take this mold left just a little bit to realign it. That looks pretty good. Now we can check front to back again. Again, looks pretty good. So we've got the mold set up. Now's a good time, if you want to, you can tighten these. Again, it's not absolutely necessary, but just gives it more stability. Okay, so we take the mold back out. We'll open this up because the next step is to actually connect up the machine and start heating up the plastic. Now, I don't recommend this when you're setting up the machine. I was careful. It's not that hot, but I've already kind of preheated the machine so that when we turn it on, we can get up temperature pretty quickly for the video. So one of the first things we want to do is we want to plug up the power cord. This is just goes into a standard 110, 120 type household outlet, 15 amp, so nothing special there. And we need to connect air. Recommend that right here's where you adjust your air pressure. So first thing you might want to do is back that off all the way counterclockwise until it is completely at zero pressure, and then you just connect your hose right here onto the fitting that's you'll see on pretty much any common air tool, shop air tool. So okay, power controller here. Where you turn the machine off and on. This is your barrel temperature, which is the main part of the heated cylinder that melts the plastic. nozzle is just this portion down here. This allows you to give the plastic one extra little push of heat right before it goes into the mold, or cool it off a little bit if you wanted to. So you can set those temperatures separately. Most of the time, I usually run the nozzle at maybe 10 or 15 degrees hotter than the barrel, just to give it one little nice little shot of heat before it goes into the mold. Back here, again, this is where you adjust the air pressure. You'll notice as I turn it now, we can start building air pressure right there. So we're going to start out with just, I want to say about 30 psi. You can push this down if you want to lock it. It's not necessary, but if you want to, you can do that. And so now it's time to turn the machine on. So we turn it on, and you'll see, you can hear the fan start in the back. The fan cools the upper part of the injection cylinder here so that the plastic doesn't melt and become a problem. So fan right here in the back. Okay, you can see, as I said, I preheated it a little bit so it didn't start out at room temperature, which might be, I don't know, 70 degrees or so in here. And we have it preset at 365 for the barrel and 370 for the nozzle. And that it seems to be a good operating temperature for the plastic we're using today. By the way, for whatever plastic you're using, you'll want to get the technical data sheet, and it will give you information such as your temperature for your heat zones. We only have basically 2 heat zones, the barrel and the nozzle itself. Commercial machines will have several heat zones. And so you will pick some of these right here, like where it says 330, 370, 360 to 440. So you will probably choose something in between 330 to 440 for your barrel. And then nozzle temperature is given 370 to 440. So you'll see we have it set on 370. Typically, with most plastics, you want to try to use the lower temperature if possible. It's just easier on the plastic. But if the plastic is viscous and you need it to flow a little quicker, you can increase the temperature, although that's not something you want to do before increasing the pressure. If you're trying to fill a mold, you want to try to increase pressure first and then use temperature as last resort to try to get the viscosity down, because at higher temperatures the plastics can tend to degrade, and well, it carbonizes and causes all kind of problems, discolorations and that kind of thing. So always try to keep your plastic as cool as possible. I may also tell you with that information whether you need to dry the plastic. Turns out this particular plastic we're using is called a TPE, or a thermoplastic elastomer. Basically a rubber is what a lot of people would refer to it as. And you want to, it doesn't require drying, so I'm kind of lucky in that regard, but some plastics do require drying and will really perform quite poorly if you don't. So we're going to go ahead and fill the hopper. You can use whatever tool you like to fill it with. I'm just using some basic kitchen measuring scoops, but you might have something that might work a little better. And then again, all right, now that we're heating up, always remember, keep your fingers and hands clear of that. As the temperature is coming up, this is a good time to start talking about safety. We're going to put on some gloves here. We're dealing with hot plastic, so some plastics are not too bad when they get molten, and you can actually, kind of actually quickly touch them and what have you. But some are, and this plastic here is pretty sticky. But some plastics will stick to you and stick to your skin and won't come off. So long sleeves, gloves, long pants, and safety goggles are recommended. Some people might even say you might want to use a face shield with an open type system like this. But most plastic doesn't really squirt, like water when it gets melted. It's more like consistency of like toothpaste or peanut butter or something like that. So, and these machines, these benchtop machines, usually don't inject quite at the pressures that commercial type machines do. So you can usually don't have to worry too much about it squirting out on you, what have you. But some plastics might have that concern. So make sure that, if you're using a plastic like that, that you have proper personal protective equipment on. But most of the plastics that you'll use probably won't fit in that category. Other things that you need to be concerned about is just the dangers of overheating plastic. And even if it's not overheated, some plastics give off noxious vapors. So if you're in an enclosed space, you may need to open a window, have a fan or some type of suction device to remove fumes. Again, look at your manufacturers, your plastic manufacturers' data sheets, MSDS sheets. Just dig all the information you can and just make sure that you understand the plastic that you're using. Some plastics can even become dangerous, like catastrophically so if overheated. So don't mean to scare you too much, but just be aware that those are out there and know what you're using. So good common plastics for benchtop molding are polypropylene, polyethylene, polystyrene, ABS, TPE. These are all good common plastics that you shouldn't have any issue with. Again, though, still check with the manufacturer to make sure that they may have some kind of additives or something that might throw you a curveball. So, okay, so we're now about up to temperature, and we have talked about safety, and so now we're ready to do the next step, which is purge the machine. We're going to open up the mold clamp. I'm going to take out the spacer for the time being. And I'm just going to put a little thin sheet of metal in here that we'll use to catch the first shot. And you want your pressure very low, something like 30 psi, what have you. Also, by the way, because yes, the machine is now up to temperature, and you'll see it actually even overshot a little bit, which is not uncommon. And what you can do to mitigate that some is you can actually lower your set point temperature, and then so that it doesn't overshoot, particularly if you have a plastic that is very sensitive to overheating. And then once you get up to that temperature and it overshoots, then you can raise the temperature slowly, and it'll keep it from overshooting too much. You want these controllers set up for precision once they've become stabilized. I mean, once this thing gets around 370 and stable, it will stay stable. But one of the side effects of that is, unfortunately, when you're starting up, is it tends to overshoot a little bit. So that's just kind of the nature of the beast. All right, so because we're making our first shots with some fresh plastic we've loaded in, it's possible there might be some air or something into the system. So we're going to do a little purging, and also if we had like old plastic from the previous time we run it, assuming it's a plastic that's safe to remain in the machine, and we'll get to that towards the end of the video. You probably want to purge that out so you can get some fresh plastic melting. So this right here is the injection lever, and we'll pull this down, and when we do, you'll see the hopper move down, the plunger will move down inside the injection cylinder, and we'll see some plastic start to extrude out of the nozzle. So let's do that now. I'll pull down on this handle. There comes the molten plastic. You can see a little smoke coming from it. It's not uncommon. Okay, and that seemed nice and quiet. You can use your tool that you're using to pinch this off. You can also use it to kind of poke the material if it needs to be poked down into the cylinder. Never, though, operate the injection handle with anything inside there. including your finger, although you can't reach it typically with your finger unless you have really, really long fingers. Use a tool and then remove it before you inject. So we want to just pinch this material off here, and we'll take it out. You can either just take this out, and you can inject onto this. Although if the plastic is really, really sticky, it might stick to your parts or something. So it might be best to use a little piece of metal, aluminum foil. You can use newspaper, cardboard, whatever, anything like that, just to that can be thrown away. So in this case, we'll dump this out. We'll reuse it. But that was a good purge, and didn't see any air. So I think now we're ready to kind of set up the mold for a shot. So we'll put a little spacer back in here. Put the mold back in. Everything should be set up. And you'll see, see I bumped the spacer. So that's one of the advantages to having the fixed. All these holes down here are meant for putting in the shim kit. So we can now tighten up the vise right here with this handle. We'll crank down on that real good. Okay, and we're ready to try a shot. Now, typically you want to increase the pressure. So I'll pull this up. Just say 40 might be a good starting place. This plastic tends to flow pretty good, but it's not uncommon to have plastics that need over 100 psi because they're so viscous. They're like cold peanut butter as they're trying to flow into the mold. So it takes a lot of pressure to push them. This is more like cold honey, I guess would be probably how this particular material. So it doesn't take a lot of pressure to get it to go into the mold. Okay, so we're up to temperature. We're starting to get stable here. It's had time to soak into the plastic. We've purged the machine, set the mold up. Everything is clamped nice and tight. So we're ready for our first shot. So we'll pull down on the handle. Oh, and we see a problem. You see the machine move up? As I adjusted the machine, I forgot to adjust these at the top. So, probably made a good part, but you'll see that was a problem, and I'm glad we did that so we can see it. So, what we want to do is, I'm going to go ahead and adjust these first and get the machine level. And you do that by you can just kind of feel, and you can tell when each nut is making contact equally with equal pressure. And you can verify that if you want to with a tape measure. You can come here and measure between the injection unit and the base of the machine, and you want all four to be equal. But once you get used to it, you'll kind of know how to do it by feel. So sorry about that, but I'm glad I actually made that mistake so I can show you what not to do. So these can, probably be hand tight, but just take a wrench and just give them a little. The whole purpose is just to deal with the reaction force of the nozzle making contact with the mold. So, okay, we probably still made a good part because I saw it make contact, even though it moved up much more than the available stroke of the nozzle. But let's see. If not, we'll learn from it. Let's see what we got. Yeah, it did okay, but you can see there's quite a few bubbles in it, which is still could possibly be some air entrained in it. But more than likely it was also due to not having enough injection pressure because it just moved out of the way. So we'll call that a throwaway. That's like a pancake. First ones are always throwaway. Alright, so let's try again. Alignment looks pretty good, although it looks like it could go to the left a little bit. I think I'm going to make that adjustment. And that might have come from when we rebalanced everything here. Got us off just a little bit. Okay, that looks pretty good. Okay, let's try again. So 40 psi, everything's not. Oh, I hadn't clamped it. What would happen if I hadn't clamped it? Well, I would have injected. And I would hear oozing and popping. Probably means we'd have another throwaway. And typically, after you inject, you know, for 5-10 seconds, look at there, see? So there's what you're going to get if you don't clamp it with enough pressure. And so, yep. So we're making all kind of mistakes. That's all right. Let's see if we can do it right. So clamp her down this time. Let's give the pellets a little poke. Let's give it another shot. I feel good about this. Everything seemed to go pretty good. I counted about 10. You may find out that you can get by with 4, 5, 6 seconds. As you make parts, you'll find out what you need to do to get your cycle time down to. You may have a part coming out over 20 seconds. You know, if you got everything dialed in just right. So, okay. So and then, you know, maybe 10 seconds or so to cool. And we open it up, and that looks like a much better part. So we can take, this right here, by the way, can be due to injecting too fast. Some materials, I think this material has a tendency to do that. If you inject too fast, it can cause it to make a little discoloration right there. You just trim your sprue off, and there you got a functional part. All right, well that's about it. So, so let's say you've made several parts now and you're ready to shut the machine down. What do? Well, this particular manufacturer on the data sheet recommends that you chase the plastic with a polypropylene or polyethylene. So one of the first things you would do is, I've got a lot in here, so I won't do that full process on camera, but you would just purge it all out. And I recommend that you don't leave the, particularly as you're starting to empty the machine, you don't put the plunger down in here too far and leave it for extended periods of time. Because what can happen is the plastic can freeze around the cold plunger and kind of creates a vacuum, and then when you when you pull it back up, it creates a vacuum in the chamber, and then once that vacuum is released, it kind of, you know, would move quickly, and you might find it startling. It's no harm to the machine, but you might find it unnerving. So just don't let the plunger stay down very long in the machine. We'll purge some more out. And if you're impatient, you can always crank the pressure up a little more. Okay. Now it turns out I've kind of experimented with this plastic, and I'm not going to waste it because it seems to tolerate heat pretty well. I have cut the machine off and come back and use this plastic straight out from a startup cycle. So it apparently is pretty stable, particularly at these lower operating temperatures. Now if you got up in the 400s or whatever, it might be different. I don't know. I don't have to do that. It operates at very low pressures and very low temperatures. So it's a pretty easy to use plastic. So anyway, that is pretty much the process. Again, check with your plastic. You may need to purge it out with some different type of material, but for today I think we're going to call that it, and thanks for watching.